Alright, so to continue from where we left off in the previous video, I want to go ahead and start talking a little bit more about our try and catch blocks, as well as also introduce an additional piece of code that comes with that, which is going to be the finally block. The way that I want to go about addressing this now is with a slightly different example, where now instead of looking at exceptions dealing with the scanner class, I want to look at IO exceptions. So to take a look at this, we're going to go ahead and create a new program or a new project. So we're going to go ahead and do our IO exception demo. So we'll have our class header. We'll then have the body of this with our main method. So we'll have public static void main. We'll have our string array of arguments. And inside of here, what I'm going to need are two different things. I need a wildcard import to just go ahead and import all of the classes within the IO package. I'm also going to need to include an import to grab the scanner class, since what I want to go ahead and do is let the user just input the name of a file and then use that name to go look up that file and read from it. So we'll come over here to the top of this program and we'll include these two import statements. So we'll do our wildcard import to just go ahead and import everything from the IO package, and we'll also do our scanner import. So we'll go ahead and do java.util.scanner. One of the things to note about this wildcard import, in addition to all the different classes that we've seen previously from our IO package, things like the print writer, file writer, the file class, there's also an additional class that we've been working with. You may have already kind of noticed this from the previous video where I did the exception demo. There was a slight mistake that I had made about forgetting to import the input mismatch exception, because of the fact that that's its own class with its own additional import. The same is also true anytime that we did the throws clause in the method header for our main method. We had throws IO exception, and this IO exception that we have right here, this is also another class all its own. Okay, and we've also kind of made a little bit of a note about that from that hierarchy of classes that I showed. We've got our IO exception, and we've also got specific kinds of IO exceptions like the file not found exception. So for this particular example, I'm not going to be including a throws clause. Instead, what I want to go ahead and do is work with try catch blocks. And in order to set this up, there's a couple of different variables that I'm going to need to include. So the first thing is going to be the scanner class. So I need to make an object of that to get the user's input. So we're going to have scanner keyboard equal to a new scanner object, say system.in. Since this one's going to be used to read from our standard input stream. We can also go ahead and include a variable for the user's input, which is going to be the name of the file that we want to read from. So we're going to call this file name. This will initially be just an empty string. In addition to this, we also need a second scanner so that whenever we open the file, we want to read from it. And in order to read from a file, we need another scanner object. For this one, I'm going to call this input file. And for this one, since we've not yet established what we want to scan, so we don't know the file that we're going to read from, when I first initialize this, I'm just going to initialize it to null. On top of that, we know that we're going to need to create an object of the file class that we can then put into this scanner so we can actually open the file and read from it. So we also need to go ahead and create a file. For this one, I'm just going to call it file, so just with a lowercase f. This one also we don't actually know until after the user has provided that input. So this one I'm also going to make null. And then finally, I'm also going to include a second string for when we read a line from our text file. We can go ahead and store that into this string variable, so then later we can do something with it. So we're going to say string, and this one's going to be file line. This is going to be equal to an empty string. Okay. Now that I've got all my variables set up, I know that I'm going to need to create a file of some kind so that I can open that up and read from it a little bit later. So I'm going to go ahead and create a new file within my Java projects folder. If you're doing this from an IDE, then just make sure that you are creating this text file in the project directory for your IDE's project. For this one, I'm going to call it hello.txt. Just go ahead and give it that name, push enter. We'll go ahead and set up in here the phrase hello world. Okay, So go ahead and include this one statement so we can go ahead and grab that later and just print that to the console. So then what I want to go ahead and do is have my statement. So I'll just go ahead and ask the user to please enter the name of the file. And then right underneath this, we'll just go ahead and do an assignment reading from the user's input. So we're going to say file name is equal to keyboard.nextLine. And for this particular line, I'm going to, in this example, just assume that the user is going to give us valid input. So I'm not going to worry too much about trying to create an additional try block just to be able to handle this. I only want to focus on IO exceptions for this one. So then once they've given us that, we want to be able to take that file name to create our file. And then once we've created our file, we're going to pass that into our scanner so that we can read from that file. So we're going to have our try block. And right here, we'll do this file that we have right here. And say this is equal to a new file object. And we're going to pass in the name of the file that we're making for this object. And then after that, we'll make our set up our scanner, this input file. And say this is equal to a new scanner object. And we're going to pass in this file into our scanner. Go ahead and save that. The next thing we can go ahead and do is then take the input file. So now that we actually have it opened to read from this file here, we can just go ahead and say our file line is going to be equal to our input file dot next line. So essentially what this is going to do is similar to our keyboard, except that now instead of getting the next line from the user's input, this is just getting the next line from this input file. And once we have that, then we can go ahead and print that to the console and also close the file. So let's go ahead and invert the order of that. We'll close the file and then print the line. So we'll take our input file and we'll go ahead and close that. And then right here at the very end, we'll just go ahead and print out our file line. Okay, so that'll cover everything for our try block. And then in addition to this, we're going to include our catch block. So we'll do a catch. And for this one, what I want to be able to catch is essentially any type of IO exception that might occur here. So we'll say IO exception. Again, we're going to use that notation of just E for the name of our exception variable. We're going to say system.out.println. And right here, I'm just going to go ahead and put a slightly different message for this print statement, where all I want to be able to check for is just the error message that I'm getting from this. So rather than using my own custom message, I want to go ahead and introduce another method that can just go ahead and produce a message for me. So I'm going to take my E, so this exception object, and I'm going to call the getMessage method. And this is just going to print out the default error message that comes with the particular type of exception that I'm getting. Depending on which type of exception I get, this get message will be slightly different. In this particular case, we are primarily going to be focusing on a file not found exception. So now that we've got all this set up, we'll come over here, go ahead and compile our IO exception demo. And then we'll go ahead and run it. And so now we'll go ahead and enter the name of the file. So in this case, we'll start by just entering it correctly. So we'll say hello.txt, or just our hello text file, push enter, and we see that we get the phrase, that statement that was inside of that file, printing to the console. So we see hello world there. Alternatively, if we try this again, but maybe we attempt to enter the name of the file, but we misspell it in some way, say something kind of like this, if we push enter, now what we're going to see is we've got the name of our file, and it's going to say no such file or directory. So this is going to be that sort of default error message that we're getting from our file not found exception. So it's warning us that we can't actually find it. Okay. So there are a couple of things about this that I want to modify. To start off with, I want to introduce this concept of a finally block. And the reason that I want to do that is because of the fact that I want to address a particular issue with organizing the code this way inside of our try block, which is primarily to do with the fact that we've got this line right here and then this line right here, both inside of our try block. But there is this possibility, maybe instead of getting a file not found exception, we might get some other type of exception, say somewhere along the way in line 21. And if that happens, we've still got our input file set up right here, but we never reached line 22 to actually go about closing it, meaning that once we're done with all of this, if somewhere later in this program, right here, we say do something else with the file, well, we can't necessarily do just anything else with the file because we accidentally forgot to close this, this input stream to read from it. So I want to go ahead and correct for this, and the way that I want to do that is I want to take this line and go ahead and move this into a different block that comes with this try catch, which is going to be a finally block. So we're going to add another little piece of code right here at the very end. We're going to take this close, we're going to cut that out from that line, and we're going to insert it into this finally block. And what this is going to do is now, regardless of whether or not we hit any kind of exception inside of our try block, anything that is located inside of the finally block is something that we will always execute regardless of whether we get through all of this or we'll go through just some amount of it and then enter the catch block. So the purpose here is essentially to say that, regardless of whether or not we hit an exception, we want to always make sure that we close the file. So if we were to come back over here to our terminal, we can go ahead and try to compile this. So go ahead and give that a shot. And then we'll go ahead and run it. And we'll go ahead and say, please enter the name of the file. So say we enter it correctly. And everything works just fine. So now let's test it after adding that code to that finally block. What happens whenever we do it incorrectly? So go ahead and misspell the name of the file again just to see what happens. And when I do this, we get the exception, but then we run into a little bit of an issue right at the very end, which is that another exception occurs in our finally block, telling us about this null pointer exception. And the reason that we're getting that is because of the fact that back up here, when I made my scanner, I initialized it to, or initially had this input file pointing to a null reference, hence why we see this null pointer exception. And so then, when I tried to set it up so that it was actually pointing to a scanner object, this ends up failing. This gives us our exception or our error in this code. So we never actually do this. So then when I come over here to close that, what I'm trying to close is essentially the null that it's still currently pointing to, but that's not something that I can actually close. So instead, I'm getting this null pointer exception because of the fact that that doesn't work the way that I intend for it to. So one of the ways we could fix this, we can just go ahead and change this to say that it's equal to a new scanner. If you wanted to, you could say that it's a new scanner that just tries to scan an empty string. So basically it scans nothing. So this is kind of a workaround for that if we want to avoid that particular exception. So if we come back over here, we'll go ahead and clear this. We'll compile it again. And we'll run it again. And this time I'll go ahead and just test it with the error immediately. And now we can go ahead and just see the our output message for our exception that we're trying to catch without any additional errors occurring. Okay. So clearly doing it this way seems to be a bit cumbersome. We have to introduce an additional finally block just to be able to close it. And also we've got to adjust our scanner initially to do this sort of odd workaround to be able to get that to work properly when we try to close it. So ideally, we want to look for a slightly more concise way to do this. And I want to take a moment going into the next video to look at a more concise way to approach this setup. One other thing that I want to go ahead and take care of in this particular example, the way that it is right now, another thing that I want to go ahead and try to fix is the message that I'm getting. So right now, we're doing this little statement here where we say that we take the name of the file and we specify no such file or directory. So obviously, for us as just typical users, this seemed to be a pretty useful message to get. It tells us, the reason that we're not able to open this file is because it just doesn't exist. But there is a bit of caution with having a message like this, which is that by testing out enough of these different kinds of messages, by trying to open various types of files on your computer system, you run the risk, if you allow somebody else to use this, to be able to look through another person's file system and be able to identify what files are inside of it. So in some cases, when you're dealing with a malicious user, they might be able to use this to gather more information than they should possibly be allowed to gather about another person's computer system. So what we can go ahead and do instead of printing out this message, we can just give a more general error and say something like, say like invalid file IO. So just as a simple example of this, basically just saying like maybe just in a very general sense, something went wrong while we were trying to process this file, whether that was opening the file, whether that was after opening the file, actually reading from the file. Maybe in the case of reading from the file, you, instead of doing next line, maybe you're using a slightly different method and you're getting some different kind of exception or error from this. So if we do this instead, we can compile it, we can run it, and now if we get an error of some kind, now it'll just say invalid file IO, so it'll warn us that there's something going wrong with it, but it doesn't give us so much information that we could learn something else about, say, the overall file system of the computer to avoid providing too much information. So the general rule here is that you want to provide only enough information as is needed for the user to determine that something has gone wrong and not provide any additional information beyond that. Okay. Alright, so at this point, this is going to complete everything that I wanted to talk about for this try, catch, and finally block, primarily looking at dealing with file I/O. Going into the next video, I want to take this approach that we have right now, and I want to kind of condense this down into a more concise and arguably a more secure way of dealing specifically with file I/O by looking at the try with resources block.